All right, so now we are on factoring. So the first thing we're going to talk about is one, what is factoring? And then two, there's going to be two elements of factoring that we're going to talk about. Factoring out the GCF, whatever that is, and then factoring out x squared plus bx plus c. Hopefully this will make a little more sense as we get there. But first things first, what is factoring? So when we factor a polynomial containing the sums of monomials, this means that we are finding an equivalent expression that is a product. And if you remember what product means, product is just a fancy word for multiplying, right? So it's the opposite of this process of multiplying polynomials. It's the opposite of multiplying polynomials. So if we can think about stuff like this. So if you have, let's say, x times x plus 2, right? Well, if we multiply these together, we can use the distributive property, right? And so this is just x squared, right? X times x plus 2x. So if we go this direction, it is called the distributive property, right? We're doing distribution. However, if we're going in the opposite direction, if we start at x squared plus 2x and we end at x times x plus 2, this is called factoring. So we're basically undoing exactly what we've just already been talking about with the multiplication. And likewise, right, remember if we have multiple stuff, so that's one form of factoring. However, since there's multiple ways that we can multiply polynomials, there will be multiple ways of factoring as well. So for instance, if we had this, remember we distribute the x to the x plus 2 and the 3 to the x plus 2, right? So that's x times x, which is x squared. And we got 2x and 3x, which will be 5x. And then plus 3 times 2, which is 6. All right, so again, if we're going in this direction, this is distribution or also multiplication, however you want to think about it. But going in the opposite direction, if we start here and we want to end as a product, then that is factoring. So hopefully this gives you a better idea of what factoring is. We're basically doing the exact opposite of what we've already done. So polynomials that cannot be factored using integer coefficients. Remember, integers are 0, 1, 2, 3, all the way up to infinity, -1, -2, -3, all the way down to negative infinity. We call these prime polynomials. So if a polynomial cannot be factored using integer coefficients, right, using integers, then it's a prime polynomial over the set of integers. So we call it prime, which makes sense, right? If you can't, if we talked about factors of, for instance, 8, right? We say factors of 8 could be 2 and 4. However, factors of 7, right? There's nothing that really can factor into 7 except for 1 and 7, so we call 7 prime. It's kind of the same way with polynomials. So first, let's talk about factoring out the greatest common factor. So that's what that GCF meant, the greatest common factor. So greatest common factor abbreviated by GCF. This is an expression. So first, let's just kind of think about, let's break down all those words before we move on. So greatest common factor. First, factors. So a factor, right, is just anything that can multiply to get something. So we've already talked about how a factor of 8 would be 2 and 4, right? 2 and 4 both multiply to get you 8. So these are factors. Let's now talk about common factors. So common factors would be factors in common, right? So if we had 8 of 2 and 4, we could also talk about 12, right? So 12 would also have 1 and 12. It would have 3 and 4, 2 and 6, right? These are all the factors. If we listed out all the factors of 8, that would be 2 and 4, 1 and 8, right? So the common factors of 8 and 12, we can see, well, we got 1, we got 2, right? And we got 4. The greatest common factor, I'm sure you can pretty much guess what this is. It's the common factor that is the greatest. So the greatest common factor between 8 and 12 is just going to be 4, right? That's the biggest number, the greatest of all of the common factors. So if we're trying to find the greatest common factor of a polynomial, right? This is an expression of the highest degree that divides each term of the polynomial. So we also have variables now, right? So the variable part of the greatest common factor is always going to contain the smallest power of the variables that appears in all terms of the polynomial. So let's look at some examples. So, well, I guess first let's talk about strategies for finding it. So when finding the greatest common factor, you basically just want to find the greatest common factor of all the numbers, of all the coefficients. And then you want to find the greatest common factor of each variable. So if you have multiple variables, you want to do each of them individually. And then lastly, we just multiply the factors from steps 1 and 2. So find the greatest common factor of just the numbers, find the greatest common factor of each variable, and then multiply all of them together. So looking at an example, find the greatest common factor of each of these lists. So we got 6x cubed and we got 10x squared. So between 6 and 10, right? So we might need to do these number trees potentially, or just listing all the factors out. So we can see that 6, right? 6 has factors of 1, 2, 3, and 6. For 10, we see that they have factors of 1, 2, 5, and 10. So the greatest common factor of these numbers is just going to be 2, right? 2 is the biggest of the common factors. All right, next we got x cubed and x squared, right? So these are the two variables. X is the variable, right? So what is x squared? What's another way to write x squared? Remember, it's going to be x and x times 2. So x can multiply, and also x squared can multiply, right? And also 1, right? Because x times x is x squared, which means x is a factor. 1 times x squared is x squared, which means 1's a factor, and x squared is a factor. And then for x cubed, we can see it's basically the same thing. We can see it's 1x, x squared, and x cubed, right? Because again, we can see that x times x squared is x cubed. So remember, you add up the numbers, that's going to be a 1. So x is a factor, x squared is a factor, and then 1 times x cubed is x cubed. So 1's a factor, x cubed is a factor. So out of all of these, right, what's going to be the biggest, the greatest common factor? And we see in this case, it's going to be x squared. So the greatest common factor of the variables is going to be x squared. So our final answer for the greatest common factor is going to be the product of both of these numbers, or both of these terms, right? So the official answer is going to be 2x squared. That is the greatest common factor of the entire monomials, 2x squared. And if you notice, just like we said earlier in the definition, right? For the variable, it ends up being the smallest number, right? 2 is smaller than 3, so it's x squared. All right, let's do another one. So we got 15y to the 5th, negative y to the 4th, and 27y cubed. So again, let's do all the numbers first. So we got 15, we got negative 9, and we got 27. So 15, what are all the factors? 1, 3, 5, 15, right? And we can talk about positive and negative, right? Technically, negative 1 also works, right? Negative 1 times negative 15 is positive 15, which means that negative 1 is a factor and negative 15 is a factor, right? So that's why the negative is for, but that would also mean positive is as well. For negative 9, we can also see that 1, 3, and 9 are, right? Because 1 times negative 9, 3 times negative 3, 9 times negative 1, right? All are going to get us negative 9. We could include the negatives, but since we want the greatest number, none of the negatives are going to be the greatest, we can see, right? And then 27. So we get 1, 3, 9, and 27. So out of all of these, which one is the greatest factor? We see it's 3. So when we multiply, we know that 3 is going to be the number. Then we can look at the y's, right? So another way we can write it as y cubed, y to the 4th, y to the 5th. So y cubed is just y times y times y, or y cubed, right? So we can, I mean, you can see, right? It's going to be the smallest number. If you actually wrote them all out. So this is another way you could do it. Whichever way works for you, I am all for. So again, there's 3 y's in common with all of them. So that's just going to be y cubed. Or 3 is the smallest exponent, so y cubed. Any way you want to think about it. All right. Ooh. Let's do one last one. So we got x to the 5th, y cubed, x to the 4th, y to the 4th, x cubed, y squared. So first, again, we're going to do each variable individually. So we get x to the 5th, x to the 4th, x cubed. So hopefully by this point we can see pretty easily which one's going to be the greatest common factor. And it should be x cubed, right? And then for the y's, we get y cubed, y to the 4th, y squared. So out of all of these, which one's going to be the greatest common factor? Y squared. So when we multiply these two together, we end up with x cubed, y squared. And that's our answer. All right. So we talked about finding the greatest common factor. Now let's talk about factoring out the greatest common factor. There we go. So when we factor out the greatest common factors, this is the first way that we can actually factor things out. So this is using the opposite of that distributive property. So we're going to determine what the greatest common factor is. Number 2, we're going to express each term as a product of the greatest common factor and its other factors. And then we use the distributive property in that other direction to factor out the greatest common factor. So let's kind of walk through these steps. So first, determine what the greatest common factor is. So of this, right, we can see that there is no variable here, so there's not going to be a variable. So the greatest common factor is just going to be 5. So that's step 1. Step 2, express each of them in terms of as a product. So if we have 5 times x squared, we see that's just 5 times x squared. So pretty dumb. We can also have 30, and we see that 30 is 5 times 6. So if we rewrite it, if we rewrite our expression, we can see that 5x squared plus 30 is just the same thing as 5 times x squared plus 5 times 6. So if we use the reverse distributive property, right, we take out the 5, what are we left over? Right? We are left over with an x squared and a 6. So we have officially factored out. And we can double check ourselves if we go back, right? If we work backwards, we say 5 times x squared is 5x squared. 5 times 6 is 30. And we see that's just exactly what we started with. So we did it right. So this would be the factored form. All right, let's do another one. So first things first, step 1, find the greatest common factor. So we can see that out of the numbers 18 and 27, hopefully we can see that 9 is the greatest common factor, right? 9's in common with both 18 and 27. If you need to write them out, right, we have 18. So 1, 2, 3, 6, 9, 18. For 27, 1, 3, 9, 27, right? So 9's the biggest of the two. Again, I obviously can do this a little faster, so if it takes you a little longer to do it, that's totally okay. Then we look at the exponents, the variables. We can see that x squared would be the greatest common factor. So then step 2, let's rewrite them as a product of 9x squared. So 18x cubed plus 27x squared. So if we break this down into 9x squared, what do we need to multiply by 9x squared to get 18x cubed? Let's look at just the numbers. What times 9 is 8? Hopefully we see that that's 2. And then what times x squared is x cubed? Well, you just need one more x, so it's positive x, just a regular old x. All right, then we get 9x squared. So again, we can kind of work backwards. What times 9 gets us 27? Hopefully we all said 3. And then what times x squared gets you x squared? Well, just 1, so we don't have to write that. So using our reverse distribution, right? We take out the 9x squared, and what are we left with? So from this term, we see that we're left with a 2x. From this term, we're left with 3. So 2x plus 3, and that's our final answer. All right, 2 more examples. So looking at this one, we can see that the great number 1, greatest common factor. All right. So you can see that 4 is in common with all of these. So 4 is going to be the number. What's going to be the variable? Hopefully you saw that that's going to be x cubed. Step 2, we want to write each of them as a product with the greatest common factor, right? So for the first one, 4x cubed times what gets us 16x to the 5th? So we can, again, do these step for step, right? So first let's look at the numbers. What times 4 gets us 16? We see 4. What times x cubed gets you x to the 5th? Hopefully you see there's just 2 more that it needs to get to x to the 5th, so that's x squared. So plus 4x cubed. I mean, you can keep the minus, I guess, if you want. That's fine. Yeah, let's just keep that minus. So we take the 4x cubed. So what times 4 gets you 12? 3. What times x cubed gets you x to the 4th? Hopefully you see that's x to the 1st, right? 1 more away. Plus 4x cubed times. So what times 4 gets you 4? 1. What times x cubed gets you x cubed? 1. All right. So this one, this term right here, that's going to be the super important one. This is the one that everyone's going to forget about. If you don't necessarily take these steps, that's totally okay, but just be aware that this is the case that people forget about. They assume, oh, we take it out of this term, it's the same thing, so it's just 0. That's not how multiplication works, right? So you end up being 1. So then lastly, step 3, when we do the distributive property, we take out the 4x cubed. So from the first term, what are we left with? We see it's 4x squared. What about the next one? Minus 3x. What about the last one? Plus 1, right? And essentially what we're seeing is, right, when we take out the 4x cubed in the first term, what's left over? We take out the 4x cubed, we're left with 4x squared. And for the second term, if we take out the 4x cubed, what are we left with? Negative 3x. And if we take out the 4x cubed in the last term, what are we left with? Just 1. So that's all we need to do. That's our final answer. All right. Last one like this, and then we'll do something else. Almost, kind of. All right, so once again, let's just go through the steps. Step 1, greatest common factor. So hopefully we can see that 9 is in common with all 3 of these numbers. So we see that 9 is going to be the number. Okay, let's look at the x's. So we got x squared, x, and x. So that means x is going to be our greatest common factor for the x's. And then we got y cubed, y squared, y. So, again, that's just going to be y because of that y at the end. Step 2, let's rewrite these as a product of the greatest common factor. So for the first term, we have 9xy times what? So we can work backwards. What times 9 gets you 27? That's 3. What times x gets you x squared? X. What times y gets you y cubed? Y squared. All right. Then we do minus 9xy, greatest common factor, times what? So what times 9 gets you 9? 1. What times x gets you x? X. And then what times y gets you y squared? Y. Oh, sorry. What times x gets you x? It's 1. Yeah. So we end up with just y here, right? Plus 9xy. All right. What times 9 is 81? 9. What times x is x? Just 1, so we don't have to write that. And then what times y is y? 1. Don't have to write that either. So then lastly, doing the distributive property. So we want the 9xy on the outside, and then basically we got to see what's left over. So for the first term, we see that we get 3x y squared minus y plus 9. And that's our final answer. All right. So what if we're factoring with a negative coefficient in the first term? So what if the first term has a negative? Well, typically we want to include the negative when we are factoring things out. It'll make things a lot easier later down the line. So first thing we do, we just factor out a regular greatest common factor. Then what we want to do is we want to factor out the negative. So we just do everything we already did, factor out the greatest common factor. We just need to do one extra step and factor out a negative. And we do that by switching the signs of each term of that other factor. So we take out a negative and we switch the signs of everything else. So let's see what that looks like. All right. So when it comes to this one, step 1, greatest common factor. So hopefully, again, we can see that the greatest common factor of all of the numbers is going to be 3. For the a's, our greatest common factor is going to be a squared. And for the b's, we should see that it's just regular old b. So step 2, let's rewrite everything as a product. All right, so the first term, 3a squared b times what? What times 3 gets you negative 18? We get negative 6. What times a squared is a to the 4th? A squared. What times b is b cubed? B squared. Plus, let me rewrite the greatest common factor. All right. So what times 3 gets you 6? 2. What times a squared is a squared? Well, that's just 1, so we don't have to rewrite that. What times b is b squared? See, that's just b. Minus, let me rewrite the greatest common factor. So what times negative 3 gets you negative 15? See, that's positive 5, right? What times a squared gets you a cubed? That's just a. And then what times b is b? Just 1, so we don't have to write that one. All right, step 3, we take out the greatest common factor. What are we left with? So as we can see, if we take out the greatest common factor of the first one, we get negative 6a squared b squared plus 2b minus 5a. All right. However, remember, we said that we want to make sure to take out that negative. We want to make sure that this has a positive coefficient on the front end. So we take out a negative, and we just switch the signs of everything, right? So instead of negative, the first one will be positive, and then negative, and then positive, right? We're just switching all the signs. That's positive 6a squared b squared minus 2b plus 5a, and that'll work every single time. And that's our final answer. All right. Last thing we want to talk about for this section. How do you factor out a squared plus bx equals c? So so we can see in here, right? There's nothing in common with any of these, right? We can't factor out a greatest common factor. X isn't in common with all of them, and there's no numbers in common with them because there's just a 1 right in front of this x, right? So how can we factor this out? So if you notice, this is going to be something closer to what we were talking about at the very beginning, where we multiply fractions, right? This is what it's going to have to look like. Something like this, right? So it's not really going to be the opposite of distribution will be the opposite of multiplication and multiplying fractions, which we said it's all the same. All right, so we want to make sure this only works for when the leading coefficient, so that is the one on the squared term, is 1, right? So the number in front of the x squared is 1. This only works in this case. So first, we know what the first two terms are, right? If we multiply everything out. So we noticed earlier, what times what gets you x squared? X, right? X and x gets you x squared, right? So essentially what we need to know is x plus what times x plus what gets you x squared plus bx plus c. So what we need to figure out is what is this m and n, right? What are these values? Okay, so bear with me. I want us to see something real quick. So let's give us some space. All right, so this is where I'm getting this from. So we need to figure out what is the m and what is the n to get us whatever this is. So let's just look at this side, right? Now this, you don't necessarily need to know how we're doing this or what we're doing, but this will explain why we're about to do the next steps in this formula of how to figure this out. So if we just multiply this out normally, right? Remember this is going to be x times x plus n plus m times x plus n, right? Just kind of a distribution and then distribute again, or distribute again. So x times x is x squared, x times n is nx, m times x is mx, m times n is mn. So how can we combine like terms? Well, if you see, here's an x and here's an x. So we can say x squared plus, we can kind of do what we did earlier, right? Factor out the greatest common factor, which would be x in this case. So that would be n plus m times x, right? Plus mn. And again, if this is confusing, don't really worry about it. I just wanted us to see, for those of us who are a little interested in wanting to know why we're doing what we're doing, this is why we're doing what we're doing. So what we see is, right, since this equals x squared plus bx plus c, what we see is that when you multiply those two numbers, the two numbers that we're trying to figure out, they should multiply to get us c. And when you add the two together, because remember, it doesn't matter what order you add things in, right, you should end up with b. So this is how we're going to try to work backwards and figure out what are those two letters that we're trying to figure out. What are those two numbers? We know that they both have to multiply to get us this constant, the one without the x, and they need to add to get us the coefficient right in front of the x. So if we go back, right, so this is the way we set things up. So we know that the product of our two numbers has to be, right, we already said that it has to be c, right? When you multiply these two numbers, they need to be whatever c is. So because of that, we need to list the factors of c. And actually, now I'm thinking about it, this may be better if we just go along with this and look at an actual example. So let's do example number 7. So x squared plus 6x plus 8. So we know, step 1, right? We know x plus something times x plus something has to equal x squared plus 6x plus 8. So let's look at 8, right? So what are all the factors of 8? We know that 1 times 8 is 8. We also know that 2 times 4 is 8, right? So these are the factors. All right, so that's step 2. Step 3, since the sum of the two numbers, when you add them together, that has to equal b, then we just need to add up each of these pairs until you get b. So what's b in this case? So in this case, what do we get for b? So we notice b is the one in front of x, so that's just 6. So what we need to do is we need to add up all the numbers. So 1 times 8 is 8. What's 1 plus 8? That's 9. Is that what we wanted? No, remember we wanted 6. We want this b. So that's not our pairs. What about 2 and 4? So 2 times 4 is 8. What's 2 plus 4? That's 6. And that's exactly what we wanted, which means these are our two numbers. So when we factor it out, we get x plus 2 and x plus 4. And we're done. And so lastly, what we can do is, if we want to, we can just check our work by multiplying them out. You don't have to do this, but it's a good way on a test. If you're trying to figure out if you have it right, that's a good way to just double check yourself. So if we multiply these out, right? So we get x times x plus 4 plus 2 times x plus 4. X times x is x squared. X times 4 is 4x. 2 times x is 2x. 2 times 4 is 8. When we combine like terms in this inside, 2x plus 4x is 6x. Which, if we notice, that was exactly what we started with. So we know we did it right. Cool. All right, let's do a ton more examples until we feel comfortable with it. All right, so really, ultimately, when you get down to it, it's really just steps 2 and 3. So first, what are the factors of 6? We see it's 1 and 6, 2 and 3. So they need to make sure that when we add these together, we end up with -5. So when we add these together, what do we get? So 1 plus 6 is 7. So that's not what we want. 2 plus 3 is 5. It's not -5, so that's also not what we want. So let's think about this. Are there other numbers that would work? So they're not other positive numbers, but there are other negative numbers that would work. We kind of talked about that a little earlier. So what are the negative numbers that are factors of 6? What negative numbers multiply together get you +6? We see -1 and -6 work, right? -1 times -6 would get you +6. And -2 times -3 would also get you +6. So if we add these together, what's -1 plus -6? And this might be a little tricky, so remember, if you're $1 in the hole and then you get $6 more in the hole, you're going to be more negative, so that's -7, which is not what we wanted. All right? And then if we have -2 times -3, right, $2 in the hole, $3 more in the hole, we see we're at -5, and that is what we wanted. Which means that we can factor it out to be x minus 2, x minus 3, and that's it. That's all it is. We're done. All right, let's do number 9. So, again, we'll have x plus something, x plus something. So let's look at 35. -35. So -35, we already start with the negative. So -35, that could be -1 and +35. It could be +1 and -35. We could have +5 and -7. We could have -5 and +7. So when we multiply these together, we end up with -35. So what we got to do is we got to add these together and see what we get. So -1 plus 35, that's going to be 34. That's not what we wanted, because we're trying to get +2, right? That number in front of the x. 1 plus -35 is going to be -34. Still not what we wanted. 5 plus -7 is -2. No, we want +2. 5 plus 7, there we go. That's our +2. So we see that our final answer is going to be x minus 5 times x plus 7, and that's our answer. All right, let's do another one. This time we have y's. So make sure you have a y instead of an x. Good. So looking at negative 99, so that might be a little tricky, so we can kind of go plug them in as we go. So again, we got positive 1, negative 99, negative 1, and positive 99. When we add these together, right, 1 plus negative 99 is negative 98. That's not what we want. Negative 1 plus 99 is 98. Again, not what we wanted. All right. Well, 3 should work. So we could divide by 3, right? 3 divided by 9 is 3. 3 divided by 9, or 9 divided by 3 is 3. 9 divided by 3 is 3. So 3 and negative 33, negative 3 and positive 33. So when we add these two together, 3 plus negative 33 is negative 30. Not what we want. Negative 3 and 33 is positive 30. Again, not what we want. Okay, what else multiplies against negative 99? 9 should work, right? Yeah, 9 divided by 9 is 1. 9 divided by 9 is 1. So we can make one of them negative and one of them positive. All right, what are we trying to get again? Trying to get negative 2. So 9 plus negative 11 is negative 2. And that's it. So we don't even have to worry about the last one because we already found it. So this is going to be y plus 9, y minus 11. And that's our answer. All right, let's do some more. So now we're back to x's. So let's talk about negative 5. So we get 1 and negative 5, negative 1 and positive 5. Are there any more? No, because 5's prime. So the only thing that works is 1 and negative 1. So when we add these two together, 1 plus negative 5 is negative 4. Is that what we wanted? No, remember we want positive 1 now, because there's a positive 1 right in front of that. We just assume it. If we do negative 1 plus 4, or negative 1 plus 5, we end up with positive 4. Is that what we want? That is also not what we want. Well, since there's no more factors, what does that mean? So it means that it cannot be factored, right? Which means that this is prime. This is a prime polynomial. It cannot be factored. Okay, let's look at some weird ones. So what if we have something like this, where we have multiple factored, we have multiple variables? Well, we can see that once again, x and x works. So that's the first term. What about the last term? So we can see that since it's a y squared, the last term should also contain y's, right? Y times y is y squared. So the first term will just be x's, and the second term is going to be something y. We just need to figure out what is that coefficient in front of the y. Good. So we took care of the variables. Let's look at the number. So we got 6. So that's 1 and 6, 2 and 3. When we add those two together, well, we get 7 and 5, which not what we wanted. We wanted negative 5. Wait a minute, this sounds a little familiar. Remember, let's do the negatives. So negative 2 plus negative 3 is negative 5, right? So we get x minus 2y times x minus 3y, and that's the answer. And if you're a little confused and not sure about any of that, well, let's multiply them back through. So x minus 2y, x minus 3y. X times x minus 3y minus 2y times x minus 3y, right? Using that kind of double distributive property. So we get x times x is x squared minus 3xy, just kind of making it look a little prettier, put them in alphabetical order, minus 2xy plus, because negative and negative, 6y squared. Because 2 times 3 is 6, y times y is y squared. When we combine the like terms, because we have xy and xy, so we can combine those just like any other term. So we end up with x squared minus 5xy plus 6y squared, which is that what we wanted? That is absolutely what we ended up with, right? That's what we started with. So that's why we know this actually does work. So we may feel a little iffy about that, so let's do another one. So we got x squared and we got a y squared. So we're going to start with our x's like always, but this time, right, since we have a y squared at the end, we know that there's going to be a y at the end. And then now we just need to figure out what are the numbers like always. So we got 3. So 3 is going to be 1 and 3. When we add those together, we get 4. That's not what we wanted. We want -4, right? You can't just make it work if it's, oh, it's just negative. Nope, doesn't work that way. So we got to think of some other ways. So what other things multiply to get us +3? Well, we got to think of negatives, right? So -1 and -3 would work. When we add those two together, we end up with -4. And there we go. So x minus 1y, which is just minus y, right? We don't need to put the 1 in front of it. And then x minus 3y. And that's our answer. All right. 2 more, and then we'll be done. So, in actuality, what we should always do, because let's look in this case, right? So remember, the only way that this works is if we have an x squared plus bx plus c. There has to be a 1 in front of it. There's no 1, though. Oh no, doesn't work. So what we can do is we can kind of combine the two concepts that we've already talked about, right? So the first thing we talked about was factoring out, factoring out the GCB, or GCF. So this is what we always can do, right? We can always factor out the GCF first, just to make things a little easier on us, and then we can see what's going on. So let's see if we can factor out the GCF. So the greatest common factor, hopefully we can see that that's going to be 3x, right? Out of all the numbers, we get 3, and then out of all the variables, we get x. So if we factor it out, so I'm just kind of, since we already took a long time doing it, hopefully we can just kind of see me doing it, what I'm doing, right? So let's look at the first term, right? So what times 3x gets us 3x squared? So we can say what times 3 gets you 3? 1, so that's cool. What times x gets you x cubed? X squared. Minus next term, right? So what times 3 gets you -15? -5, and that's where that negative came from originally. What times x is x squared? X. Minus what times 3 gets you 42? I don't know off the top of my head either. So let's just divide. So 3 goes into 4 one time. Bring down the 2, and that's a 4. So 14. And then what times x gets you x? 1. Good. So hopefully you saw that we did literally the same thing that we've always done. We just kind of made it a little better, or simplify it just a little bit, right? So factoring out the greatest common factor, this is how we did it. Now, can we factor this out? So can we keep factoring? Let's check. So what are the factors of 14? So we know it's 1 and -14, right? So 1 and -14, -1 and +14. We also have 2 and -7, -2 and +7. So then let's add these together. 1 plus -14 is -13. That's not what we want. -1 plus 14 is 13. Still not what we want because we're trying to get -5, right? Not -15 anymore. We're doing the smaller one over here. Yeah, we've already factored out the 15. We're not looking at this anymore. Then we got 2 plus -7 is -5, which is exactly what we wanted, right? So we can factor this into what? What can we factor that out into? So we can see that it is going to be x plus 2 and x minus 7. However, don't forget, this is super important. When we factor things out time and time and time again, you have to remember we started with that 3x out front. So we also need a 3x out front for our final answer. Do not forget, that's super important. Make sure if you factor out a greatest common factor, that greatest common factor is also there when you've factored out the final answer. All right, last one, and then we'll be done with this video. All right, -16t plus 16t plus 96. All right, so Again, these are going to be t's this time, so not x's. So make sure everything goes into t's. This is not a 1, so let's factor out the greatest common factor. So we can see that there's no variable that's going to work for all of them, but hopefully some of us can see that 16 will work. So what times 16 gives us negative 16t squared? We see it's negative t squared. What times 16 is 16t? Just plain old t. And then what times 16 is 96? So may have to think about this a little bit, but it's actually 6. All right, so we can check it out. 16 times 6, we get 36. So bring down the 6, carry the 3. 6 times 1 is 6, plus 3 is 9, 96. However, remember I said when we have the leading coefficient is negative, we want to also take out that negative. So when we take out the negative, what do we do with everything else? Remember, we just switch the signs. So positive, negative, negative. So this will be positive t squared minus t minus 6. And now we end up with that 1 in front of our t squared. So we can actually do this. And that's why we wanted to make sure to factor out the negatives earlier. Cool. So let's do what we always do. 6, negative 6. So that's 1 and negative 6, negative 1 and positive 6. So if we want to just add them first, without just seeing if these work, 1 plus negative 6 is negative 5. Not what we want, because what are we trying to find? Hopefully you all thought negative 1, right? There's an invisible 1 right there, so we want negative 1. So not negative 5. Negative 1 plus 6 is positive 5. Again, not what we wanted. All right, so what else multiplies to get us negative 6? We got positive 2 and negative 3, negative 2 and positive 3. So if we add 2 plus negative 3, you end up with negative 1. And there we go. So since it's t's, remember, this is our line. So it's going to be t plus 2, t minus 3. And what have I forgotten? What do we say that is really important from that last equation? Last problem. Remember that negative 16 out front. You also need to remember that. All right, good. So next video, we'll talk about what do we do if we have an a in front, right? If we don't have a 1 in front and it can't be simplified. So for instance, how would we factor 3x squared minus 20x plus 28, right? Well, 3 isn't a common factor between 3 and 20, and there's no x's for all of them, so there's nothing we can do to simplify it like we did the last two examples to make it an x cubed. So how do we figure this out? Well, that'll be the next video. All right, if you have any questions, like always, let me know. Otherwise, I will, hopefully you'll look at the next video.